everyone, hope all of you are doing well. Today we are going to continue plus 2 previous years question paper discussion. We can discuss the questions of higher secondary examination March 2010 to 2022 in chapter wise. In part 1 we have discussed the questions from the chapter electric charges and fields. Now we can continue the discussion with March 2020 and June 2019 years of question paper. Now we are going to discuss the questions from March 2020. The first question is, a permanent electric dipole of dipole moment P is placed in a uniform external electric field E as shown in the figure. Question A, redraw the figure and show the magnitude and direction of force acting on the charges. And B, write an expression of the torque acting on this dipole in vector form. We can redraw the figure as shown in the diagram. Here we can see that the force on charge plus Q is QE, and which is acting along the direction of electric field, and the force on minus Q is minus QE, and which is in the direction opposite to E. Also the torque acting on the dipole, that is vector tau, that will be equal to vector P cross vector E. Now we can move to question number 16. An infinitely long straight wire with a uniform linear charge density is shown in figure. Here we have to draw a Gaussian surface in order to calculate the electric field at P and mark direction of electric field at this point. And the second question, derive an expression to calculate the electric field at this point. So the score is 2 plus 1. So total 3 marks. Here we can see the Gaussian surface drawn in order to calculate the electric field at P, and also the direction of electric field is as shown in the diagram. In order to derive the expression for electric field at P, we can consider a thin, infinitely long straight rod having charge density lambda. Here lambda is equal to Q by L. For finding the electric field at P, we can imagine a Gaussian surface which is passing through P, and then we can apply Gauss's law. According to Gauss's law, we have integral E dot ds is equal to 1 by epsilon 0 q. That E dot ds we can write as E ds cos theta. Then the equation becomes integral E ds cos theta is equal to 1 by epsilon 0 q. Here we have Q is equal to lambda L and theta equal to 0. Then cos theta will be equal to cos 0, that is equal to 1. Then we can write the equation as E ds is equal to lambda L by epsilon 0. Here the field is radial everywhere, so the flux through the two ends, that is the upper and lower surface of the Gaussian surface, will be 0. That means E and ds are perpendicular, so that E dot ds will be equal to E ds cos 90, that will be equal to 0. Therefore no need to integrate the upper and lower surface, and we can integrate over the Gaussian surface only. Here we have E into integral ds is equal to lambda L by epsilon 0. Here integral ds is the area of curved surface, that is equal to 2 pi RL. So we will get E into 2 pi RL is equal to lambda L by epsilon 0. When we rearrange, we will get E is equal to 1 by 2 pi RL into lambda L by epsilon 0. That can be written as 1 by 2 pi epsilon 0 lambda divided by R. The same question we have already discussed in the previous question paper also. Now we can move to the questions of June 2019. The first question is a 1 mark question. The question is, the value of electric field inside a charged conductor is dash. The answer is 0, because inside the shell the Gaussian surface does not enclose any charge. Next is a 3 mark question. Question number 12. The first question is, name the theorem used to find the electric flux through a surface enclosing charge. The second question is, using this theorem, derive an expression for the electric field due to an infinite plane sheet of charge with a surface charge density sigma. Now we can answer the questions. The theorem used to find the electric flux through a surface is Gauss's theorem, and the B question we have to derive the expression for electric field. So in order to derive the electric field at a point P, that is at a distance r from the sheet, we can imagine a Gaussian surface in the form of a cylinder having the area of cross section ds. It is shown in the diagram. Here the plane sheet of charge is having a density sigma. Now we can apply Gauss's law, that is integral E dot ds is equal to 1 by epsilon 0 q. Here we have q is equal to sigma into ds. Therefore, E into integral ds will be equal to sigma ds divided by epsilon 0. Here the electric flux passes through the circular faces of the pillbox only, and there is no lateral flux. Therefore, we can write integral ds is equal to 2ds. That is, E into 2ds will be equal to sigma ds divided by epsilon 0. When we rearrange the equation, we will get E is equal to sigma ds divided by 2ds into epsilon 0. So that we can write it as E is equal to sigma divided by 2 epsilon 0. Now we can move to the next question. Question number 19. An electric dipole is placed in a uniform electric field of intensity E. Let theta be the angle between dipole moment and electric field. Then A. Derive an expression for the torque acting on the electric dipole in vector form. B. What orientation of the dipole corresponds to stable and unstable equilibrium? And C. Write the equation of potential energy corresponds to a stable equilibrium. Here the torque tau is equal to P cross E, and the derivation we have already explained in the last video. And the question B, for stable equilibrium theta should be 0, and for unstable equilibrium theta should be 180 degree. Also the potential energy U is equal to minus PE cos theta, or U is equal to P dot E. Today we have completed the question papers of March 2020 and June 2019 of chapter Electric Charges and Fields. In the upcoming videos, we can discuss the questions from the question papers of 2010 to 2018 in chapter wise. If you like my video, please like, share and subscribe. Thanks for watching.